Hi, Mr. Tucker. I had a question for you really quick, if that's okay. Oh, where's the sound? Okay, cool. I'm on my way to an appointment right now because I had an issue last night with my baby. Will you be having a test opportunity on Friday and then next week on both of those classes as well? Because I have like 3 more tests that I have to get done and then I'm done.
Yep.
Okay, beautiful. So there will be a test opportunity on Friday, Monday, and Wednesday?
Yes.
Perfect. Thank you so much. And as well as the recordings for the day, will these be posted as well just for the last one? Because I'm leaving at this moment.
Yeah, most definitely. Most definitely. I'll try to get it out to you guys today, but if not, most definitely by tomorrow.
Beautiful. Thank you so much, sir. I appreciate it. I hope you have a wonderful day.
Not a problem. Hope you do the same. Hope everything's all right.
Yeah, I'm fine. I just I had severe abdominal pain, and because my daughter is low sitting, so with that, they told me if I had any severe abdominal pain that I needed to come in to be checked out.
Gotcha. All right.
Well, thank you so much, sir, and I hope you have a great day.
Thanks. I hope you do the same. Take care.
Okay, bye-bye.
Bye. Good morning to everyone else. Sorry I had a sneeze. You gotta hit that mute button real quick when you sneezing in everybody's ear, right? So we have one more section that we're doing today, which is 18.6. So let me go ahead and head to the notes. All right, so we're looking at graphing of quadratic equations. All right. And let's see where we're going first. Find a vertex. So let's go to this notice for me. 161. Let's see what section this is. I think it's like 2.1. Maybe it's in chapter 3. Yeah. All right, so this is 3.1. All right, so we're looking at graphing quadratic functions. So the graph that we will get whenever we're looking at quadratic functions is your parabola. And it can go concave up or concave down. So concave up is the U shape. Concave down is flipping it upside down. When it's concave up, we have a vertex at the bottom, and that's our lowest value, our minimum. Is concave down, our vertex is at the top. So our vertex will be the highest point, which would be considered our maximum. The coordinates of your vertex is always considered HK. All right. Everybody done with the graph? All right, so your standard form of your quadratic equation of a times x minus h squared plus k. Let me see, they call it standard form. That's all right. And so if a is greater than 0, then it's considered concave up. In other words, if a is positive, if a is positive, concave up, it opens upward. If a is negative, then concave down. Also notice that h and k is a part of that standard form. And whatever your sign is, and we'll emphasize it more when we get our numbers, whatever the sign is for h, it's the opposite sign in your coordinates. Notice we have a positive h down here. And then k is what it is. But like I said, we'll emphasize that more when we get down to some numbers. All right, gonna scroll up. All right, so if we want to graph quadratic functions with the equation in standard form, I think another book called a standard form. Anyway, it doesn't matter. We're going to determine your concavity. So is A positive or negative? That's going to dictate that. Determine your vertex, find any X-intercepts, find any Y-intercepts, intercepts, and then plot the points 2 through 4. And then if you need any additional points, you can do that as necessary. All right. I'm gonna come back to this. I want to see if I have an example of a certain type of problem. Looking for something. Okay, I have to come back down and do a problem like that. Okay. All right. All right, can I scroll up? Okay, so the first one that we'll do, notice the problem is already in our standard form. Gonna have to do a problem that's not in the standard form, so we'll come back and do that. I just want to do the problems that we have up to this point. So first thing we look at, first step that we have is determining our concavity. A is -2, so that means it's going to open downward. All right. Our vertex, remember, it's the opposite sign for H, so that's why we have +3, and then K you just use as is. That's why it's +8. All right. Questions on the coordinates of our vertex? All right, so to find your X-intercepts, if any, remember whenever you're looking for X-intercepts, you let Y be equal to 0. And then whenever you look for Y-intercepts, you let X be equal to 0. So remember, f of X and Y are interchangeable. So our Y in this problem is f of X. So we let f of X be equal to 0. That's what I did right here. So this is f of X being equal to 0. And then I went ahead and solved for X. First thing I did was Subtract 8 from both sides. Then here, divide by -2. Now I need to get the square off of x minus 3, so I took the square root of both sides. Don't forget, last class we talked about the square root property. So taking the square root of both sides means I have to do plus or minus. And that's why I have plus or minus 2. Then I add 3 to both sides because I'm still solving for x. I want to get x by itself. And that leaves me with x equal to plus or minus 3 plus, well, x is equal to 3 plus or minus 2. All right, so then to finish it off, 3 plus 2 is 5, 3 minus 2 is 1. So my coordinates would be 5, 0, and 1, 0. Because remember, y is equal to 0. So x equal to 5 is 1 point. X equal to 1 is another point. And so that's 5, 0, and 1, 0. And I'm gonna come back to this, but if you go back to the diagram, what I didn't point out is right here are our x-intercepts. That's where the graph intercepts the x-axis. We'll go back, look at the scenarios in which you'll have x-intercepts and y-intercepts as well, but just pointing that out. So you should have 2 x-intercepts. All right. Any questions before we go to y-intercepts? All right, so for y-intercepts, we let x be equal to 0. So you plug in 0 for x wherever you see x in the problem. And that's what we did right here. So that's 2 times -3 squared plus 8. -3 squared is 9. -2 times 9 is -18. -18 plus 8 is -10. And so here is our y-intercept. And notice the coordinate is 0, -10, because we let x be equal to 0. Any questions? All right. So then you go ahead and graph those points and to give yourself a rough sketch of what your parabola will look like. All right. Everybody good? All right. So now let's say if our equation, our quadratic equation is not set up in that standard form. Let's say if it's set up in our general form. And see, I think that other book I used called this one the standard form, called that the standard form, but anyway, it doesn't matter what you call it. It's in this form right here. All right, so what we would do, A is sitting in front of x squared, B is sitting in front of x, and then C is the term, the constant term that is not attached to a variable at all. I can find the vertex by doing this right here, -b over 2a, and then take -b over 2a, plug it into the function, and that would be my y component for my vertex. In other words, k. Let's see, did I do the whole thing? Yep, did the whole thing. All right, so let's take this and do the same steps So now I'm going to find my vertex using this method. So we see A in this function right here is -1. So that means our parabola is going to open downward. All right. Now, if I want to find the x component of my vertex, which is H, I would use this -b over 2a. So b is -2, a is -1. Plug it into this formula. Make sure you don't lose a negative. That's -b over 2a. So I'm plugging in -2. So that's going to be -2 up top. And then 2 times -1 down bottom. That simplifies to -1 for H. Now to find K, my Y component of my vertex, I take the -1 and plug it into my original function. And that's what I did right here. And that ended up giving me 2. So my vertex is -1, 2. Any questions? Any questions? So now we'll do the other. Now that was the only different step compared to last one because how the quadratic equation was presented to us. From there, we'll do the same things that we did in the last problem. Your y-intercept, to find your x-intercept, we're going to let y be equal to 0. Now, this function is not factorable like the last one. I believe we did the last one through factoring. Let's see, or did we need to? No, we use a square root property solve because of the setup. Okay. So now if this was factorable, I will go ahead and factor this one, but it is not. So we have to use the quadratic formula. That -b plus or minus square root of b squared minus 4ac over 2a. Plug in your values accordingly. A is -1, B is -2, C is +1. So here we have -2 plus or minus square root of -2 squared minus 4 times -1 times 1 over 2 times -1. So -2 is +2. On the inside of the radical, we have -2 squared, which is 4. Then -4 times -1 times 1 is +4. So that's why we have 4 plus 4 here. That's 8. And then I just needed the decimal values because remember, I'm going to graph this. So I just went ahead and converted them to decimals. 2 plus square root of 8 over -2. 2 minus square root of 8 over -2. Gave me those values, -2.4 and +0.4. And those are my ordered pairs for my x-intercepts. All right. Let me scroll up too fast if everybody's copying. Next one, your y-intercept, let x be equal to 0. So you just plug in 0 wherever you see x into your function. And 0 squared is 0, 2 times 0 is 0, plus 1. So that's just going to be 0, 1 as our y-intercept. All right. And that's the rough sketch of our parabola. We just graphing all of those points that we just found. Any questions? Let's see, do we need to do this for you guys, max and min? Yeah, you talk about it. Okay. Okay. So another thing to talk about before I write some other stuff down. If A is greater than 0, in other words, if your parabola opens up, concave up, then F has a minimum. We talked a little bit about it earlier. At X equal to negative B over 2A, that's your vertex. And then if your parabola open downwards, then your function has a maximum at your vertex. Remember, negative B over 2A is where your vertex is located. All right. So here it says consider f of x equal to negative 3x squared plus 6x minus 13. First, they want you to determine whether it has a minimum or a maximum value. A is equal to negative 3. Remember, that's what's sitting in front of x squared. That means it opened downward. So that means it has a maximum value. Then tells us to find a vertex. Remember, we can do so by taking A, which is negative 3, and B, which is 6, and plugging it into negative B over 2A to find the X component, find the H, which will simplify to positive 1. Then we'll take that positive 1, plug it into the function to find K. There we go. So doing so, it's negative 3 times 1 squared plus 6 times 1 minus 13. Of course, 1 squared is just 1. Negative 3 times 1 is negative 3 plus 6 minus 13. And that simplifies to negative 10. So that's what negative 10 as our vertex, which is our maximum. All right. I don't think you guys are talking about domain and range. All right, any questions on that? We won't do domain and range. Your book doesn't ask you about it, so we're good to go. We won't throw anything extra at you. But before I go to the other page, everybody good? All right. Let's see, find vertex and intercept. I will just do this to, just in case they ask. All right, so just in case they give you this, I don't believe I did one. where they ask you to write this in that form of a, if like they give you the general form initially and ask you to convert it to this form. So we have x squared minus 4x minus 12. First thing we can do, let's go ahead and just for shorthand purposes, instead of keeping f of x, go ahead and interchange that with y. All right, next. Yeah, I don't know if that's really a step. Yeah, do that. So I'm going to move the constant to the side with y. This is what we're looking at now. I guess we could have called this our first step. All right. We're going to do a little bit of completing the square. So we're going to take half of b So add the result on both sides. I'll leave it where it is. Plus, all right. All right, so I'm going to simplify and then factor the trinomial. So now this is, we did do completing the square. So as far as your factorization goes, whatever half your b term was should be what this factor down to be. So we should have 1 plus 16 equal to x minus 2 squared. Any problems? So now we're going to take the 16 and move it back to the side with the x's. So we're going to subtract 16 from both sides. All right. So x minus 2 squared minus 16. And then we're going to put that f of x back for y. And that's our answer. All right. Questions on what we did there? Problems? Any problems? Any problems? Everybody good? All right. One last thing, and then that'll be it for this section. Just a little bit of, let me see. Give me 1 second, Mr. Hudson. I'll go ahead and look at that for you. Let me write this down real quick. All right, so for the first one, parabola opens up. So if your vertex is in quadrant 1 or quadrant 2, then you're not going to have any x-intercepts. If your vertex is in quadrant 3 or quadrant 4, then you'll have 2 x-intercepts. And this is just an example, if it's in quadrant 1 or quadrant 2, the diagram right here. If your vertex is in quadrant 1 or quadrant 2, notice how, erase. There we go. So this was in quadrant 1. Notice it's going up. So the x-intercepts are down here as far as your x-axis is concerned. And then here, quadrant 3, since it's going up, it's going to touch at both of these points, which are our x-axis. I mean, which is our x-axis, which are, those make up our x-intercepts. So remember, the x-intercepts is where the graph crosses the x-axis. All right. Can I scroll up and do the last one? We're good. Just down, all right. Consistent, yep. All right, so then if your parabola opens down, if your vertex is in quadrant 1 or quadrant 2, you'll have 2 X-intercepts. And then if it's in quadrant 3 or quadrant 4, you will have no intercepts. All right. Any questions on anything I've written? All right, Mr. Hudson, it's asked about testing opportunities. So we're gonna have one on Friday at 10. And then we most definitely will have Monday and Wednesday of next week. So right now we have 3 in the books that you guys will have, the opportunity to go ahead and take your tests. All right. So we'll see about next Friday, but we know for a fact I'll do this Friday and then Monday and Wednesday of next week. All right. Questions? Any questions? Good. So I'll check my schedule for next week to see if I can find some other opportunities, but we know we got 3 for sure. All right.
Going to be having a test on Friday too?
Yes, what I said. Yeah, this Friday, and then Monday and Wednesday of next week.
Okay, thank you.
So like I said, I don't know about next Friday. We'll see about that, but I know for a fact we got 3 opportunities. We got this Friday, and I got to send you guys that link. And then we have Monday and Wednesday, which is regular class period. Monday and Wednesday of next week, regular class period, because we don't have any more new material. So it's really just Monday and Wednesday of next week if you want to take a test. Or if you want to ask questions, you can ask questions as well. What I would say, for somebody who is taking a test and don't want to hear me talk about something because I'm disturbing, all they gotta do is mute me, and then they'll be able to, take the test, still be on Zoom, but take the test and don't have to listen to me talk. So, all right. Any other questions, concerns, comments before we close? Everybody good? Everybody straight? All right. Well, you guys have a good one. Be safe. This is our last section of new material. Like I said, no more new lectures from this point forward. We're good to go. And now it's just about closing everything out, making sure we knock out all of those tests. If you don't know, if you need more than 3 opportunities, then most definitely got to get with Mr. Davis, because I'm not sure, how many more I'll be able to offer. I will check and see, but you want to make sure you have all of your ducks lined up or lined in a row, whatever the saying is. All right. So if you guys are good, I'm good. Have a good one. Be safe. And for those of you who are coming on Friday, I'll see you Friday. If not, I'll see you on Monday.